practice test, can we go over a couple homework questions?
Oh, guys, today is anything.
Alright.
Nobody has asked any questions about the practice test at all. You know, so yeah. So what do you got?
5.2, number 60 and 70. Get it right.
Oh yeah. 60 looks funky. I like it.
Yes.
So let's see. Let's talk about a few first steps on number 60. Let me get rid of. Just erase the earth and the sun environment. Secant theta minus tangent theta squared, is that?
Yeah.
Plus 1 over theta.
Cosine, or cosecant theta.
Where'd it go?
Tangent
Cosecant
theta.
theta. Equals 2 tangent theta. Right?
Yeah.
And I know that's obvious, but I still want them joking. It's not obvious. Yes.
Can I get a practice test?
Sure. All right, so obviously this side has more you can kind of sink your teeth into. You can do some stuff on the other side, but I don't know if anything I would do there would be helpful. Yeah. This side's got a lot of stuff I can kind of work with. So, did anybody try this problem? Even if you didn't get it done, did you try something? Or if you're first gazing upon this problem right now, okay.
What problem is it?
60, right?
Yes.
Yeah. In 5-2. Can somebody tell me the most basic identities that we know? Huh?
The Pythagorean?
Yeah, the Pythagorean theorem ones, right? So what's the most basic one of those? Sine squared theta plus cosine squared theta is 1. And then you can build the other ones from there. So whenever I see trig function squared, I think, oh yeah, Pythagorean identity might be useful. And I don't see anything squared yet, but I do see these would be squared if I did what with this?
Distributed property.
Yeah, if I FOIL it out. So, let me tell you something I tell my tutors. I always tell my tutors, if somebody comes to you with a problem, that specific problem does not mean shit. That specific problem doesn't mean shit. Do you think I'm going to give you this problem on the test? This exact problem?
No.
Hell no. I'm going to give you a problem like this one. So what is always important is, why am I doing what I'm doing? No matter what the problem is, what is it that's telling me what to do, right? So since a lot of our most basic function identities are ones that have squares in them, right? That's one of the first things I could look for. Is anything squared? Does the Pythagorean theorem help me? So nothing's squared yet, but if I did FOIL this out, they would be squared. Now, real quick, you can also notice on the bottom, like what's cosecant?
1 over sine.
1 over sine, and what's tangent? Sine over cosine. Do you see how the signs would cancel? I mean, so you can kind of look for that kind of thing also. Well, let's not do too much at once. Can you guys just I'm not going to do this whole problem, by the way. I'm just going to do the first couple steps. Can you guys FOIL this out? So, of course, something squared means that thing times itself. Can you FOIL it out for me?
Secant squared theta plus secant theta times tangent theta.
So minus another one, right?
Yes. Tangent squared theta.
Plus tangent.
And then there's a plus 1, yes?
Yeah.
So I'm just looking at the top, just looking at the top.
Oh boy.
What's tangent squared theta plus 1?
No, secant.
Secant squared theta. Right? You guys with me?
Is it secant or cosecant?
No? Co stuff goes with co stuff.
Okay.
Does it make 1 plus
Yeah.
cotangent squared is cosecant squared, 1 plus tangent squared is secant squared.
Okay.
So that's one really base level of why we called certain things co and certain things not co. Because they go together, and that's the first level of what I can see how they go together in those identities. Yeah,
Those are copacetic.
totally. Copacetic. Capiche? Okay. So is there any agreement that tangent squared theta plus 1 is secant squared theta?
Yeah, okay.
And don't I have another secant squared theta?
Yeah.
So don't I get 2 secant squared theta on the top? Okay. So that's the top of it, correct?
Mhm.
Now what can I do with the bottom of it? Like I said a minute ago, just look at it, so it's the top, let's look at the bottom.
So the second part.
So let's leave this alone for right now. What happens here?
The sign goes with.
It becomes,
Yeah, the sign cancels, correct?
it becomes.
And what's one over, I'm sorry, go ahead.
How'd you get 2 secant squared?
Oh, sorry, so there's a secant squared here.
Yeah.
Plus another secant squared.
Okay.
Yeah.
Thank you.
You're welcome. So that's the top, and now I'm looking at the bottom. Is everybody with me on this? So then I get secant theta, cosecant theta, minus, what's 1 over cosine?
Cosecant.
1 over cosine?
Secant.
Secant.
Yes.
S goes to C, C goes to S. Sine theta goes to cosecant
Yes.
theta. Cosine theta goes to secant theta. S goes to C, C goes to S. Let me stop for a minute. Now this gets tricky, because I took the top and worked on it by itself, and I took the bottom and worked on it by itself. Sometimes students don't put those back together correctly. But I still like to break a problem down into parts, because I don't want to look at this whole fraction at once, there's a lot going on. Does anyone, so now if I put this back together, the top over the bottom, does anyone see anything that could happen here? What do the top and the bottom all have?
They all have secant.
They all have secant. So can't I take a secant out of the top? Can't I take a secant out of the bottom? So then these cancel. I love you guys. You guys are all like, yeah, you can do that. Okay. And then you just kind of got to keep going. You know, what else can I see? What else can I try to do here? Right? Now this is my first inclination of something to try, because I saw several things that I could simplify. You guys all with me? Not really.
So you can take
Yes.
So, what I did was I did, like from the beginning, I just did 1 over cosine theta minus sine theta over cosine
Wait. So
At the very
where are we looking?
at the very beginning.
Sure, very beginning. What part?
Uh,
Oh, here?
yeah.
Oh my God. Okay, if you want to, I guess. Yeah.
Yeah.
Sure.
Yeah.
So then once you get to 2 secant theta minus two tangent theta, you can take a two out,
You could, sure.
Can you just make
and
the
then use
bottom
reciprocal identities.
go tangent?
How do you
no,
make?
it's not squares.
So keep in mind, I'm trying to make it look like this, right?
Oh,
Oh,
Well, no, so you gotta be careful. I see that here, don't I?
yeah,
But I'm still not near it. It's just one piece of this thing, correct? So now if you want to, I would say you can change everything into sine and cosine. I can't remember if that's the section where it said to do that.
and, oh wait, no, that's not cosecant squared, never mind.
Now here's exactly where I need you to understand something very important before you leave. What is a part of any problem like this? Any problem like this, a part of it is
Sine and cosine.
trying the wrong thing, correct? Now, I'm not saying what I did was wrong. This is just what came to mind, right? I'm not gonna do the whole damn thing for you, though. So it's all about trying what you can do, trying something, and seeing if it leads you closer to what it's supposed to look like. If I change everything right now to sine and cosine, I might be able to do some more stuff, yes? But we did quite a bit. We managed to get some stuff canceled. I see the answer there, sort of. So I feel like maybe I'm going in the right direction here. If I can just kind of keep going. You could rewrite everything in terms of sine and cosine. You could see what that gets you. You could multiply top and bottom by something.
Could you factor out a two?
Hmm?
Could you factor out a two on top? I guess
Yeah, yeah, like John said, you could factor 2 out. Sure. Yes.
if we make the secant 1 over cosine, are we allowed to cancel it? Like, can we move the cosine? to
Where, I'm
multiply?
sorry, which part?
With the 2 secant theta.
Yeah.
We know that it's 1 over cosine.
Sure.
So, can we make the cosine go on the bottom and multiply?
Yeah. Okay, so we can rewrite this as 2 over cosine. And this is 2 sine over cosine, right?
Yeah.
Do you see how they have like denominators? Okay, this is what I'm talking about. So I'm not gonna, I need you to, you're all this, yeah, you just, all right, let me give you a little bit more. You guys agree with me on the top there?
Yeah.
And then the bottom would be 1 over sine.
Minus one.
Okay, I like it.
I knew that.
So, love you guys. Yes?
So, someone may be wondering why that wouldn't be like tangent squared. For the bottom cosecant theta minus one.
Well, it's not squared, so it's not really one of the
Yeah, now,
identities.
someone may be wondering why you didn't put tangent squared there.
Or cotangent squared,
Or
I guess.
cotangent, yes.
Yeah, because it's not squared, so the Pythagorean identity needs things to be squared to work.
Yes.
Yeah. I like it. Yeah,
So for the, how do we get rid of the 2 secant theta next to the?
well, we're kind of working on it, right?
No, that was 2 steps back.
I'm sorry, how did we?
Yeah,
Which
on the
piece, I'm
top.
sorry, so on the top, I took a secant theta out,
But it's 2 secant.
squared. So don't each of these terms have a secant in them? Don't each of these have a secant in them?
Yeah.
So if I take 1 out, there'll be 1 left here, because there were 2. Minus, and there'll only be a 2 tangent, because I took that one out. GCF, right?
okay.
Good old GCF.
The 2 threw me off,
Gotcha.
cause it,
I could have taken a 2 out at the same time, but I just didn't.
Okay.
Now listen, guys, are you relatively okay with everything I just did? And again, this problem, how important is this specific problem? It's not important at all, it doesn't mean shit. What's important is, why did I do what I did? And you're all like, yeah. What the shit? So I noticed if I did FOIL this, I'd have square stuff, Pythagorean identity would come into play. It makes sense to do that. So once I FOILed it, I had squared stuff. So then I could do Pythagorean identity stuff to it. Then once I did that, I noticed, oh, wait a minute. So the bottom and the top have things in common. I can kill those. Hey, great. See, I mean, so every step, it was all about what's going on now, is it an identity, is it something cancels, is it two fractions I can put together, it's all about what can I try to do, right? Now, just to show you the next kind of step here, can't I combine the top?
Yeah.
So it'd be 2 minus 2 sine theta over cosine, is that cool?
Yeah.
Over,
1 over sine theta.
to make this LCD here, what I multiply by sine on top and bottom?
Yeah.
So then it would be 1 minus sine theta over sine theta. And you're all like, sure. But if I would have done like Chad asked me to a while back, and if I would have taken a 2 out of here, do you guys see how there's something the same? So if I rewrite this, what's a better way to write fraction divided by fraction? Multiply by the LCD, exactly. I'm sorry, by the reciprocal. So it'll be sine theta over sine 1 minus sine theta.
Now, for the,
We're basically there now.
so for the 2 minus 2 sine theta, that would just be sine theta, right?
No, 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 no. The only way you can cancel that 2, because that 2 is multiplying the sign, is by dividing by 2. You can't do 2 minus 2, because I don't see 2 minus 2 in here anywhere. I see 2 minus 2 signs. And those aren't like terms. But what can I do? Can't I take a 2 out? Which is what you told me to do earlier, and I just didn't. What happens now?
They probably cancel each other out.
They cancel each other out. And what's sine over cosine?
Tangent,
So I have 2
tangent.
tangent theta.
It's magic.
Shit. I just couldn't stop myself. So there you go, so free me. Now, especially because it's done that problem doesn't mean shit. But what was the motive? Every step I took, what was my motivation? And I will be very honest with you. Right here, I was like, oh shit, did I do the right thing? I don't know. And I didn't care. I did care, but it didn't freak me out. I didn't feel like I didn't know math, because I know math. But on these problems, you could try to do something and it leads to a dead end. Doesn't mean you don't know anything. It doesn't mean you suck. It doesn't mean any of that shit. I don't care how good at math you are, when you do these problems, you will sometimes pick, let me try this. Oh, that didn't work. Who cares? I got other stuff I could try. Does that make sense? This is the first kind of problem you've seen where making a mistake is just part of the process. It doesn't mean you don't know what you're doing, right? Now, it is possible that you don't know what you're doing,
Yeah.
which just means you need more practice on basics. But if you got the basics down, there's a million different things I could try. Maybe not a million, but there's a lot of different things I could try. Why did I try what I did? The squares told me to FOIL it out, use Pythagorean identity, and then the fact that all these things ended up having something in common. Let me kill those. And then I can evaluate where I end up. I don't know if you guys are with me. Now, doesn't it make sense then? I can't give you a ton of these on a test. Because if making a mistake is part of the process, you could kind of make a mistake and you can make another mistake and then you're like, and then the test is over. You're like,
No.
I didn't get a single one done.
No,
Does that
you
make
only
sense?
have so much space on a paper.
Yeah. Huh?
Is that, where you, the last step, is that supposed to be cosine or cosine?
Here?
Yeah.
Oh, that's cosine, yeah. Cosine. Goodbye. No, that's better, but. Yeah, sorry. Who's? Yes.
And the last part, did you like from the step where you have the denominator as 1 minus sine theta over, did you like multiply the whole thing by the reciprocal?
If I have a fraction divided by a fraction, isn't that a fraction times the reciprocal? So I just took this one and reciprocated it.
Okay.
Yep.
Thank you.
There's a decent amount of algebra in here, yes? And you're all assumed to understand algebra when you start this class. Now, with that said, if you need help with some algebraic concepts like factoring, ask me, ask a tutor, ask any math person. You're in the right building, yes? You guys kind of with me? So you need to, as you do problems, you need to kind of identify where you've forgotten something. And then you just let me know. I've got all kinds of worksheets on factoring and so forth that I can go over with you. I can give you stuff so then you can go to a tutor and have problems to try out.
So when you're multiplying by the reciprocal, how'd you get from 2 minus 2 sign to just 1 minus sign?
Oh!
Like when you factor that out,
So here I factored the top out, took a 2 out of the top.
Yeah.
So I just rewrote it here, just so I didn't have to rewrite the whole problem. Is that cool? So take a 2 out of the top, and I get 2 times 1 minus sine theta, is that right?
Yeah.
Yeah, so I just gotta, so I didn't have to rewrite the whole thing, yeah. Okay, the less I write, the better normally, because look at how well I write.
A lot better than I do.
Okay, yes. Anything else about this one? Yes,
I'm a little confused.
because you're a different problem, right?
I'm a little confused at how we went to 2 cosine minus, or 2 over cosine minus,
Oh, here.
Yep.
What's secant defined to be?
cosine is
1 over cosine, yes? So 2 secant is just gonna be 2 over cosine. 2 tangent, of course, is 2 sine over cosine. Yeah. So, from the beginning you could do that, but normally it's not a good thing to do at the beginning. If you get to a point where you're not sure, then I would say replace everything with sine and cosine. Because very often you'll see more stuff you could do. So right here, none of us were sure what to do. So then I said, okay, let's change everything to sine and cosine. And then all of a sudden I could see the stuff I could do.
I was pretty much there as soon as I saw the problem.
Huh?
I was pretty much there as soon as I saw the problem.
Yeah. All right. How are the rest of those problems? Have you guys tried the rest of those? Was that one the worst one? Okay, let's talk about a few more of those if you want to. Again, that's going to be like maybe a couple problems in the test are going to be devoted to solving or proving identities, or verifying identities. Yeah.
Number 70? on
Real quick, Brandon had a question, and then
It was on 4 point something, so he could go first.
all right, either one.
Okay. 70 on 5.2?
70. Okay, cool. So everybody got what they want from this? Probably more than you ever wanted. Okay.
Luckily it's up on YouTube.
What did you choose?
You know, for 70, I just switched cosine over sine to 1 minus sine over sine.
Okay, hold on, let's catch up. So number 70 says cotangent squared minus 1, right? Over, where'd it go? There it is. 1 plus cotangent squared equals 1 minus 2 sine squared.
Yeah.
Wait, is it t's or, did they look at 2 different things? No. You just put theta in there just because.
I don't think that really matters.
Not really, but as long as they're consistent. Okay. So what was your suggestion, Brandon?
I just did, instead of cosine square over, like for cotangent, instead of cosine square over sine square minus 1, I just did 1 minus sine square over sine squared minus 1, and it just canceled.
All right. Wait a minute.
Yeah.
Sorry?
Look, just look.
Okay.
Look at it. This is what I did.
Where?
70.
70.
Yeah. I
Oh, you just replaced everything in terms of, oh, sure, okay. And then the bottom came from what fact? So you kind of skipped a step there. So help me out, guys. Do you see squares on anything?
Yes.
I see squares on every damn thing, yes? Which side has more stuff I can sink my teeth into?
The left.
The left side. So what's the bottom?
Just cosine squared.
Careful, what?
Cosine squared.
No, no. What's,
Oh,
one plus,
cosecant, sorry.
yeah, 1 plus tangent squared is secant squared, 1 plus cotangent squared is cosecant squared. I like it. And I gotta be careful, the way I say things, I gotta be real careful. If I write this, if I just write this, that does not mean anything. So like me saying, can you guys answer that question? What is that? Please simplify that. I don't wanna know what it is, just tell me what the answer is. You're like, what the shit, you didn't put anything inside of it. There we go, now I can do something. This same thing. This doesn't make any damn sense. It's always gotta be of something. Theta, t, x, something, yes? Okay. So when I say it though, I'll sometimes just say cotangent squared, but it's, to make sense when you write it, it's gotta be of something.
Yeah.
Okay. So this, tell me again what this is, I'm sorry.
Cosine squared.
Cosecant squared.
Cosecant,
Squared.
not theta, Jeff. And then the top, we'll do what Brandon did here in a minute. I always, let's see. It's a really good idea. Okay, what's the bottom?
Cosecant.
And what's
One over
cosecant related to?
Sine.
Cosine.
Sine, yes.
Yes.
Okay, let me stop for a minute. So right here is a good example of, okay, I applied a Pythagorean identity, I'm not sure where to go from here. So whenever you find yourself not sure where to go, one thing you can always try is rewrite everything in terms of sine and cosine. So what's cosecant squared? 1 over
Cosine. Sine.
sine, there it
There
is.
we go.
And cotangent squared is
Cosine over sine.
cosine
Cosine
Squared over
over
sine.
sine squared.
over sine. And Jeff, you just not even listen to yourself. Cosine over sine. Let me see if you guys can notice this. Do you see if I multiply top and bottom by something, all the fractions go away that are inside the big fraction? You guys see how this is fracception? This is fractions inside a fraction. If I multiply top and bottom by what? I cancel the internal fractions. Why are there fractions inside of this fraction? What are their denominators? Every single denominator is sine squared, yes?
Yeah.
So what if I multiply top and bottom by sine squared?
It would just be cosine squared.
The bottom just becomes,
One.
that's the
No.
best denominator ever. Yeah, the best denominator you have is 1, because then it's, don't even have to write it.
Yeah.
And what happens to the top?
Becomes cosine
One
squared.
over.
This cancels, yes?
And that cancels. Yep.
So it becomes cosine squared minus sine squared, yes? Cosine squared minus sine squared. Now look at this.
They're not the same.
Not yet, but isn't this 1 minus 2 sine squares? You do it, John. 1 minus 1 sine squared minus another sine squared, yes?
Yeah.
You guys see that? Do you guys see how this wants to be the Pythagorean identity, but there's a damn 2 there? So let me break it up, and then I've got a Pythagorean identity, yeah.
I'm a little confused about the last step. How does multiplying that big like fraction in a fraction, like you're multiplying it by sine squared, right? So wouldn't that get rid of both sine squared?
Totally, yeah, they did. They both canceled.
Oh wait, no, I just read that. Okay.
You're okay. So that's why it's cosine squared t minus sine squared t over 1. So I didn't even write that part. Is that all right? Okay, okay. What's 1 minus sine squared? What's 1 minus sine squared t? Cosine squared t. This and this. Check. So I started at one side and I made it match the other side. Yeah, so that means I'm done. This is what I need you to show me somehow that you understand what the hell you just did. If you don't put any of this down, I have no idea if you understand what just happened. So this is a nice way to tell me, oh, they're the same, I'm done. That's the quickest way to just go, I'm showing you, I understand they're the same, and I'm putting it, I know I'm done. Next problem, Jeff.
So there are some instances where you can, like simplify the right side there.
Yeah, totally. Almost always, there will be one side that has more stuff that I can sink my teeth into, yes? But then I might get to a point where I'm like, I don't see anything, so then you come to the other side, you start working on it. You're just trying to make them eventually match up. So that if I follow this, I can go from here to here to here, to there, to there, to there, to there. That means that equals that, because I can make it look like the other side. Yeah. Yeah.
Can you go over 4.3 number, starting? Please?
Oh, okay, yeah. So, guys, sorry?
I'm sorry. The check, how is it cosine, how is that minus sine squared t, and then the bottom is plus sine squared? Am I missing?
No, this is minus, yeah.
Oh, okay.
Yeah, it's minus, yeah.
Okay, I was like.
You're good.
Sorry.
No worries. So guys, help me out. What does tangent x look like? What's the major things about tangent? Where are the asymptotes that we normally draw?
Negative 5 over 2.
Yeah, negative pi over 2 up to pi over 2. Because tangent's got cosine on the bottom, so when's tangent going to freak out? Anytime cosine 0. Cosine 0 at the y-axis, pi over 2, negative pi over 2. Right. I know this is not the problem, but we got to remember how to do tangent just by itself first. What are these points here?
When it's 1.
Negative pi over 4, pi over 4. This captures the what? The amplitude, right? That's why I always put in quotation marks. It's not really an amplitude because it goes forever. There's no ceiling. But at these positions, it should equal the amplitude. So if there was a 2 there, it would equal 2 there. If there's nothing there, it's a 1, so they would go 1, 1, 0. So it approaches the asymptote, then it comes through here, and then it approaches the other asymptote. And I understand it's very difficult to make that curvy. There's a very, very minimal curve to this thing in the middle. But make your ends curvy just to make up for that. Okay. Don't just draw a straight line, because then I'm worried. You guys at all with me? Now, the actual problem is this. So that's a nice little review. The actual problem is 1 minus tangent x. So what would that do to my picture? It would just flip it, right? And then I'm going to take that negative tangent x and I'm going to move it up 1 because that's positive 1. Because another way to write 1 minus tangent x is negative tangent x plus 1, right? That actually is a better way to write it. So if I can just draw this, which means just flipping this, and then I'm going to take every point and I'm going to go up 1. So that point goes here, this point goes here, this point goes here. So now it's going to look like, I don't know why I keep doing the problems for you, Janet. I just can't stop myself.
But didn't I do it on my?
I don't know. Did I say it was wrong?
Yeah.
Oh, evil. Where?
I've given you the graph, I flipped it.
Oh. Oh, I think I got, oh, I'm with you. Negative pi over 2 to pi over 2.
Right.
Oh,
It's
but
not
this-
cosine. I mean, it's not cosine.
This, oh, I see, because you, okay, because you did everything at once. You didn't, yeah. So if you're gonna do a vertical translation, you've gotta show me the base function and then move it up. I didn't see where it was starting or where it was going to. Right?
So that's why 25 and 30 would be wrong.
Yeah,
And
but
then-
30's wrong. 25. Yeah, I don't see how you knew you're gonna start here.
Well, I do because,
did like a beginning, but it didn't really match up with where you started here. Because of that, I think, yeah. Yep, so, yeah, your work didn't match up with your final answer, so that's always an issue for me. I'd much rather you have an incorrect graph if your work's not right. I don't know if I've said this to you guys yet. If your work isn't right, I want your graph to be based on that work. So your graph is gonna be wrong, but it's gonna be right based on your work. So one thing I'm trying to grade you on is, can you take the work you did and visualize it? So the worst thing in the world is to have incorrect work and then a perfect graph. Because that graph did not come from your work, it must have come from somewhere. Okay.
Like your mind.
Like your calculator. For some people, I'm not saying you did that, but, okay, yes.
Can't we just reverse engineer it then? If we have the correct graph, can't we just figure out the correct details from the correct graph?
You could, which is why I need to see the work. And reverse engineering, you're not gonna have the correct work to show me. I don't know if you're with me or not, so.
Yeah, no, I
Yeah.
get that.
But it's not a bad idea to kind of like go backwards to figure out what you might have done wrong if your graph doesn't match. Nothing wrong with that. Does it make sense? So you kind of catch a mistake you made if you do that, yeah. Yes?
So, with the 1 minus tangent x, that's also an identity, right?
No, it'd have to be squared.
Okay.
And even then, it's sort of just, you're gonna like this tangentially related to it, an identity, yeah.
Hey, how did I get the domain one?
I don't know. So if you have a specific question on homework, just ask me after class.
Okay.
Okay.
Anything else generally from the practice test, from other homework problems? Yes?
Can you post the thing with all the graphs and that reference sheet?
Oh, yeah, if you remind me. So if somebody, so Canvas is not something that's on my routine. I am open to throwing all the handouts up there just if somebody reminds me. Does it make sense? The minute I leave this room, I'm thinking about my next class. And then Canvas is not something that's part of my routine. So, yeah. So if you want the handouts up on Canvas, just say, hey, Jeff, can you throw all the handouts up on Canvas? No problem. So now you got the old quiz, you got the homework, you got the practice test. We could do any problems from any of those. We can talk about general idea of something. It's up to you guys. Does everybody have the sine and cosine addition formulas memorized?
Can you rewrite them with the
Yeah.
subtraction ones too?
So what is sine of a plus b?
That is
Sine
sine
A.
A, cosine B.
Good, because sine's a nice guy, right?
Yeah.
So let's take turns, cosine. Alright. You got a plus, I'll keep it a plus. Now I'll do B, you do A. Whatever. Alright. Sorry, that's cosine. So then, and if this was a minus, this would be a minus, yes? Okay. So if I have cosine of A plus B, what's cosine do?
Yeah, it becomes a
Cosine A plus nine.
Me first. You got a plus? Screw you.
Yeah.
Now you just pick up the drag sign. And so if this was a minus, this would be a plus.
Yeah.
This is maybe the first time you've ever seen a plus minus sign, really depending on the order you write it in. You guys with me? Plus goes with minus, minus goes with plus, so the order I write that in actually makes a difference. Maybe. Or maybe not. Yes.
Would the minus flip anything?
With the
Or,
minus
like, not
flip.
flip, but change the sign of anything?
Sorry? Sorry,
I feel
where?
like there was something else.
Something else where? What happened?
Like, if we, like for the top, if we make it from plus to minus for the sign A minus B.
Yeah. Here?
Yeah,
Yeah, so plus goes with plus, minus goes with minus, that's what that means.
Yeah.
Yep. So your question is, if I reverse that?
no,
No, what's your question, sorry? I don't understand.
I felt like the sign would change, like, for the other.
Yeah, I'm not gonna reprove these things. So in the process of proving this, we saw how the sine of negative b and cosine of negative angle, those identities came into play. And really quickly, what is the sine of negative theta versus the cosine of negative theta? What's the sine of negative theta?
It's negative.
Yeah, it's negative sine theta. And what's the cosine of negative theta?
Positive cosine.
Yeah, and real quick, why does that make sense? Why the hell does that make sense, Jeff? Because if I have an angle, and I'm talking about the cosine, and then I look at the negative angle, does the cosine change? No, it's the same, isn't it?
Yeah.
What about the sine change? Does the sine, S-I-N-E? Yeah, it was positive, now it's negative. So that's where that comes from, and this is how you can memorize that. This is how I think about it if I don't remember it. I'm like, okay, if I have theta versus negative theta, sine changes, cosine doesn't. Why does cosine not change? Because each triangle has the exact same x side. So of course cosine doesn't change, because cosine likes x. Okay. Maybe. So I've tried to show you, so many of the things we have to memorize are built off of sine likes y, cosine likes x. Which is why I will always shit all over SOHCAHTOA. Because SOHCAHTOA does help minimally, and even then, I just have to turn my paper to make it not help more than sine likes y, cosine likes x.
But also SOHCAHTOA is mainly just for geometry.
Say again?
SOHCAHTOA is just mainly for geometry.
Even then, it very quickly loses to sine likes y, cosine likes x. But I agree with you, if I was just doing geometry, SOHCAHTOA, I could basically get through most of it. But that's not where you're gonna end with this, yeah. Okay. Anything else in general or specific?
In general, question 21 on 5.3, please.
5.3?
Yeah.
Oh yeah, perfect, okay. So, this is exactly the kind of question I'm gonna ask that's related to these, so let's see. The question is, what's the cosine of pi over 12? Did you have to memorize any radians over 12? No, it's just over 3, over 6, over 4, right? Those are the basic, over 2, those are the ones we have to know, yes?
Yeah.
So when I give you a problem like this, and it's on a section you're not allowed to use a calculator for,
So I did.
there's no way in hell to do this unless you write it in terms of angles you know. So, one way to think of this, let me just look at pi over 12. Isn't it true that pi over 12 is 5 pi over 12 minus 4 pi over 12? Isn't that true?
Yeah.
For example, now this is not good. Because do you know 5 pi over 12?
No.
But do I know 4 pi over 12? Yeah, because what's that reduced to? Pi over 3. Okay. So now it just becomes, can I think of two angles that who subtracts that I know both of them? Well, this is really close. 4 and 12 go down to 3. 3 and 12 reduces down to 4. So what if I did 4 pi over 12 minus 3 pi over 12? That's a true statement, correct? And what is 4 pi over 12? Pi over 3. And what's 3 pi over 12? Pi over 4. So this equals cosine of pi over 3 minus pi over 4. Now, did I go straight from here to here? Of course not. All I did was, what do I subtract to end up with this? Well, that's one thing. 5 pi over 12 minus 4 pi over 12. That's definitely pi over 12. Does it help me? No. So I pick something else that subtracts to be pi over 12 until I get something that reduces to angles I know. Does that make sense? Yes.
So, so like, how do you know when what numbers in what order to subtract?
Did I go into this knowing? No,
Okay.
I didn't. I took a guess. And then I saw the guess was wrong, so then I tried to work it. And so if you take a guess and you say, okay, maybe 9 pi over 12 minus 8 pi over 12, do you agree that that works?
Yeah.
What does that reduce to?
3 pi over 4.
3 pi over 4. What does that reduce to?
2 pi over 3.
2 pi over 3. Are those two angles you know?
No.
Yeah.
Let me say it better. Do they have reference angles that you know? Yes.
Yeah.
You could use these then. I'd much rather use these because these already live in the first quadrant. I don't have to do a reference angle. But do you understand how I could use these?
Yeah.
That would still work. So it is a guessing game to a certain degree, but you know you want a top that can reduce with the bottom.
Right.
So that it becomes an angle you know. And 12 is nice because 12 comes from 3 and 4, right? So that's what you're thinking about is what would lead me to have a 3 and a 4. I need numbers on the top that reduce with 12. Yes?
Or like a number.
Was that a good thing or a bad thing? You're right.
I just realized I'm gonna have a 3-year-old and a 4-year-old in like a few weeks.
Oh, I got
3
you.
and 4, and I was like, oh my god, no.
Is your
My
2-year-old
kid's
turning 3? Huh?
My 2 is turning 3.
Got you.
And I was like, oh my god, almost not.
Congrats,
progress.
dude.
I'm scared.
I understand. I understand. That's some scary times. I was dating somebody who had a 2 and a 3-year-old, and then I was with her for a couple of years. So those years are very interesting.
Yeah.
Yeah. Okay.
Is that 3 pi over 4?
Let's see. Oh, I'm sorry.
Right there. Like on the right side.
3.4. No.
No, 3
3 pi.
pi over 4.
3 pi over 4 here.
Yeah.
Yeah, because that's what 9 pi over 12 reduces to.
Okay.
Yes. Now. Yeah, if you can't read it, you can work it. What's the rule here then? I got cosine of A minus B.
So that would.
Cosine is the asshole, right?
Yeah.
So the cosine of 1.
Over 3.
Cosine of the other, right? He's me first. You got a minus. I'm gonna make it a plus because I'm an asshole, right?
Yeah.
Okay. Yes, Jeff, you. Okay, thank you.
Yes.
And then sine gets a turn finally, right? And each part of this you have memorized. You're gonna see square root of 6 and square root of 4 a lot. I mean, it's not square root of 4, but yeah, square root of 6 and you're gonna see the square root of 2. You're gonna see those a lot when you do this. Kind of makes sense, but for example, what's cosine of pi over 3?
1/2.
1/2. Cosine of pi over 4?
Rad 2 over 2.
Rad 2 over 2. There's your rad 2. So you get rad 2 over 4 for that piece. Plus, and then, I mean, keep going. Is that all right? I'm not going to
Yeah,
do
it's the
another
same
whole
thing.
problem for you. Okay. You guys kind of with me? So this is, we have things we memorize. We proved these. Now we can go one step above what we memorized and say I can now do anything that I can build using angles I memorized. So that kind of now I got more stuff that I can work by hand. And I know, I totally understand. As a student, you're like, you got a calculator, man. I am all good. And as a math teacher, I don't give a shit because the more you're able to do without a calculator, the more you understand the topic. Yes?
So, continuing on with that problem right there, that would be, 1/2 plus rad 2 over 2, which would,
Times.
yes,
So add 2 over 4, yes?
yes, so,
All right. What's sine pi over 3?
oh, okay, never mind.
Rad 3 over 2.
Rad
Times.
2, okay.
Rad 2 over 2.
So there's your rad 6 I was telling you. You will get some things showing up a lot, which kind of makes sense because they have to be built off of only certain angles. So you're going to see a lot of repeats. Because we only have so many parts to build from that we have memorized.
Rad 6 over 4.
Now, I'm going to get an answer here, right? Yeah. What if I wanted to know what cosine of pi over 24 was?
Just take what you know.
Well, now I know what cosine of pi over 12 is. I could kind of build from there. I'm not going to make you do that, but you understand what I'm saying?
You can
If I can figure out this constituent part, I can then do even further away from the angles. I might make a bonus question like that.
Just multiply everything by 2.
Huh?
Multiply everything by 2.
Well, now you can build it off of pi over 12 and pi over 3, pi over 4, right? So you gotta think about what makes pi over 24. So again, I'm not gonna do it, but break it up. Like, isn't this, for example, 4 pi over 24 minus 3 pi over 24? It's not the best example, but you'll see. So that would be pi over 6 minus pi over 8. But then pi over 8 I can get using this, for example. Yes?
Mm-hmm.
Using this idea.
Yeah.
I can get pi over 8, okay. There's an even better identity in our future. It's called a half angle identity. So it would actually directly, just any angle you know, when you cut it in half, you could use the half angle identity to figure it out. So if I know pi over 4, I can automatically know pi over 8 using half angle. Then I can know pi over 16 using the half angle identity again. And I know, you're all looking at me like, I don't need to know how to do that. And I'm saying, yes you do, if you want to pass this class. Okay.
Or the other look that we may have is like, yay, more identities.
More identities, yeah, they just never stop. There's only a certain number of identities we're gonna have to memorize, and we already know about half of them. Actually, a little more than half, to be honest. There's only a few we haven't talked about yet. In the minute that I'm done, I'll give you the big sheet of all the identities you're supposed to memorize versus all the ones you don't. So let's do this. Yes?
Speaking of identities.
I want to talk about which ones we have to have memorized right now.
It's just a general question.
Sure, good.
So for those of us that are going to continue on like chemistry and physics and whatnot, will we see these identities again?
Oh, hell yeah.
Great.
One of the ones that happens the most is that double angle formula that I can't remember now if I even talked about, but it's on the practice test, but it's in a future section.
And I think it's like, what, 5 or something?
So real quick, if I have, for example, so sine of A plus B is sine A cosine B plus sine B cosine A, right?
Yeah.
So what is sine of 2 theta? It's sine of theta plus theta. So it's sine theta cosine theta plus sine theta cosine theta. 2 sine theta cosine theta. So that is the double angle formula for sine.
Wouldn't it be 2 sine theta times 2 cosine theta?
No. What's sine theta cosine theta?
Okay,
Plus sine theta cosine theta.
okay. I see.
2 sine theta cosine thetas. Yeah.
Okay, I see.
That's kind of nice. That's a nice little thing. Thank you, sine. Cosine comes out ugly. Cosine's an asshole.
Perfect reaction right there.
Yeah, pretty much. She's laughing at what you have to go through. I laugh at your pain. Okay. So right now you have to know the Pythagorean identities, obviously, right? If you're like me, you could just memorize sine squared theta plus cosine squared theta is 1 and then build what you need from there. Or you can memorize all 3. You obviously have to know all the basic stuff from before. Sine theta is y over r, blah, blah, blah. Sine theta is 1 over cosecant theta, right? You have to know, like we said earlier, sine and negative theta, cosine negative theta, that kind of stuff, right? And then you have to know sine and cosine of sum and difference. Those are the ones you definitely have to know.
And then you get tangent of negative theta too.
Yeah, that's why I put under that, yeah, for all of them. I like it. Okay.
Because tangent just loves to be different.
Yeah, well, it's not tangent's fault, right? We built it to be sine over cosine, so it's going to have issues. We built issues into it.
Tangent is the parent of cosine and sine. How about that?
If you want, I guess. Yeah, whatever works. You can make whatever family tree you want to.
Yeah.
All right, let me give you the answer key.
The text?
So, and by the way, I don't, if there's ever anything I explain and you're like, well, that did nothing for me. Say, hey man, can you try that again? I didn't understand. I mean, that's part of my job, is figuring out how to re-explain something in a different way so that it makes sense. And that's part of what I love about this job, thankfully, or else it would drive me insane.
Yeah.
Right? Some of my the people that I went through the math degree with, they are like, Jeff, I could never be a math teacher because I just understand it, and if somebody else doesn't understand it the way I do, I'm like, well, screw that, too bad. I'm like, thank God, never become a teacher, holy shit. So especially if nobody's asking anything on review days, the floor is completely yours. And I sometimes don't know if students are hesitant to ask a question because they feel like everybody else understands. It is never true that everybody else understands anything. As a teacher, one of the weirdest things to me is when a student's doing like this, when they ask, does everybody understand? And I know they don't. But they're doing that just so I don't know, I never just made sense to me.
Yeah, you feel better.
Yeah, making me feel better maybe, and normally students don't really care that much about how I feel, so it doesn't really make sense, but So, we still have some time left. If there's anything specific or general, you could say, can we just do another example of this? Or you could say, number 27, part B, number 2, yeah.
I just have a general, something I wanna go over. Can you
Yeah.
go over identities real quick, so I make sure that I know.
Okay, so you mean the identities you're supposed to have memorized?
Yeah,
Okay.
for section 5.
Well, let's just talk about, or do you want to do an identity example, or do you want to talk about the identities you're supposed to have memorized?
Memorize.
Memorized, okay. So, like I said, you have to know sine and negative theta. What is sine and negative theta? Negative sine theta. This is cosine theta, and then you can build everything else. What must tangent of negative theta be? Negative tangent theta, yes. And then for the reciprocals, you're golden. Since sine goes to negative sine, what does cosecant do?
Negative cosecant.
Goes to negative cosecant because it's built off of sine, yeah? This is the power of knowing the relationship. I have less stuff to memorize then. Yes?
Wouldn't it be cosine negative theta equals negative?
No, definitely not.
Why not?
Of course not, no. What is cosine of 30 degrees?
1/2.
Right, 3/2.
Right, 3/2. I don't know, it's the bigger one because that's close to the x-axis, that's where cosine likes it.
Yeah.
What's cosine of negative 30 degrees? What's the reference angle of 30 degrees?
Negative.
Cosine likes x, so is it still going to be positive?
Yes.
Yes, so cosine of negative 30 degrees is exactly the same as cosine of 30 degrees. That is the way that when I didn't have those memorized directly, I just thought about this picture. Look at the sine. Sine likes y. This is positive. That's negative. There. Done. So therefore sine and negative theta must equal negative sine theta. That's not really memorizing. It's just this picture I should have in my head anyway and then using it a different way. Is that all right? Yeah.
So all these assume that the angle is less than 90?
No. They're just generally true.
But what
This is
about,
just a way to remember it.
well, the sine of, like, the cosine of negative 130?
All right, cosine of negative 130.
Wouldn't that be a negative value?
Sure, totally.
So how?
So how does cosine of negative 130 relate to cosine of 130? That would be a negative value, and this would be a
Oh.
negative value.
Oh, okay.
So that still holds. Yeah, so this is a way to remember it, and then since everything's based on the first quadrant anyway, it actually carries through the whole thing. So that's why this is a beautiful way to remember it. In fact, what's the only thing we have to memorize? First quadrant shit, because everything else is built off of that. So I keep this image in my head for remembering these. Now I've done it so long, it just sort of like sticks in my head. But when I was a student, I didn't like to memorize shit. I really, really didn't. So I just kept this in my head. I'm like, well, when I go to negative theta, sine now is negative. Cosine is the same exact thing it was before. Bam! Nothing memorized, but I know what the answer is. Okay. Yeah.
So for number 3 on the practice pad, how did you get 625 over 576 minus 1?
Let's see. Oh, I used the rule 1 plus tangent squared equals secant squared. And since I told you that secant is 25 over 24, I just squared this, right?
Oh, okay.
Yeah, to plug it into the formula, I've got to square them, right?
How is
Okay.
it,
I see that.
how is it, how did you go from secant equals 25 over 24 to 625 over 576?
I didn't, so I know the value of secant.
Yeah.
And I want to know, what was that I asked for? Cotangent. I want to know what cotangent is. I can use a Pythagorean identity to go to tangent, yes?
Yeah.
Okay, so 1 plus tangent squared equals secant squared. I know what secant is, so I can plug that in.
Then you just kind of reverse that.
And then I subtracted 1. And now I can figure out, that's the next step. That's the whatever the hell it was over the whatever the hell it was.
Oh,
Actually, it's 25 over 24.
Oh, 25 over 20, thank you. Showing off my awesome memory. Okay.
so that's how you got it, it was just squared.
Yeah, I want to know cotangent. Well, if I know tangent, I just flip it.
Right.
Alright, so I know secant, I can know tangent through the Pythagorean identity. I just have to plug that value in and I can solve for tangent.
Got it.
When I take a square root, don't have to put a plus or minus. That's why I told you what quadrant you're in, so you know whether it's positive or negative. Does that make sense? What do you square to get 9?
3.
4?
Negative 3.
Ah, so when you take a square root, you put a plus or minus. So I also will tell you the quadrant, so you know if it's positive or negative. Okay. And that's why I put a negative on the answer, because I'm in the fourth quadrant.
If we know
Well,
that
we
secant theta equals 25 to 24, can we just work at it like it's a right triangle?
Yeah, you can totally do a right triangle. And this one, I said use a Pythagorean identity.
So,
So I was being cosine.
Oh, that's normal.
Now, if I just said, given secant find cotangent, and I didn't say the rest of it, I would hope most of you guys would draw a right triangle. So for real quick, if I know this, and I draw the right triangle, what side is 25?
The Y,
No,
R, R.
the R.
Yeah.
And secant is related to cosine, so the x side would be 24. Then guess what you get here? And 25 squared minus 24 squared, you'll get 7 when you take a square root. Pythagorean identity, right? Pythagorean theorem in that case, yes?
It's a long-
So then what's the cotangent?
24.
24 over 7, and it's negative because I'm in the fourth quadrant. So I agree. What, you with me? Totally. If I didn't say use a Pythagorean identity. Does that make sense?
Yeah.
Yes. If I didn't say that part, I would hope most of you would draw a triangle, because that's the easiest way to do it.
Cosine, pi over 12 looks familiar.
No way.
Yeah.
Yes.
If you tell us to use Pythagorean identity, are we able to do it how you want us to do it and then use that to check it?
Of course, yeah. Hell yeah. Dude. Please, your guy. Part of math is learning how to check shit on the run, because when you're on the test, you have no safety net. It'd be great to know how to check your work. So hell yeah, if there's a way that's easier and I ask for the harder way, you can do the easier way real quick. Make sure you get the same answer. I love it. Little cheer. Right? Does that make sense? Just make sure you put like just checking or something, right? I don't want that to seem like that's your work. I didn't ask for that. Okay. Not a damn thing wrong with that at all. That's beautiful. Okay. And by the way, if I have a problem, you're like, I don't know what it means, just do it the way you can think of. I will give you some points. The only way to make sure you lose the most points you can is leave it completely blank or to put something that has nothing to do with the problem. Let me be careful, because I said that and somebody wrote, you said not to leave it blank, so here I am not leaving. No. If you do some work in the direction of the answer, you won't lose all the points. Does that make sense? So never leave anything completely blank. Try something. It might just be you're not confident, and that's actually the right way to go, and you'll get some points. Yeah.
I'm also just now picking up that for 3 on the practice test, that 25 over 24 is the given, that's not always.
Oh yeah, the that I gave you 25 over 24?
Yeah.
Yeah. Okay. All right. Has anyone tried out the Mass Science Center anytime recently? You guys? Some of you guys are like, probably like, I don't know how people do anything without going there.
Yeah.
Don't forget I also have office hours, but I understand if you're like, if you've had your fill of me in class, you have other people you can talk to.
What's
Right?
your office hours?
They're up on the canvas. I don't have them up here, sorry. That's why I put them up there.
They also have whiteboard tables.
Huh?
They have whiteboard tables.
Yeah, I have whiteboard tables in the Mass Science Center, and I have one in my office, which is neat. And then I have an actual whiteboard in my office. It's great.
So cool.
One thing I don't have in my office is a lot of space. So whenever I get like a lot of students, then I sort of overflow to the hallway. Yeah. Yeah.
I don't really understand how you do your conversions to degrees to radians. Because when I just do it, I just multiply it, but it's not the same answers that, like, I don't get the 209 pi over 36.
Oh, that. Yeah. All right. So 1b, I would really want you to have 7 pi over 4.
Yeah, so I don't know how you get there.
1d, I'm actually okay if you make that into a decimal because it's not like a standard one. I should have put that down there. So yeah. But like if you get 5 pi over 6, that's an angle we should know. I shouldn't make that into a decimal because now it's taking it further away from.
Yeah.
But the one that's over 30, screw that. You can make that into a decimal. That's fine.
Yeah.
Yeah.
See, but I don't know how you.
All I did was reduce it.
Like,
Right?
Reduce it by
Like, yeah,
5.
1,045 over 180. I just divided by until I got to here.
Divided by 5.
If I divide by 5, do you see that?
Yeah.
And one quick little thing. Do you guys know this? If I have any number in the universe and I add up all the digits and they are a multiple of 3, 3 goes into the whole number. Have you guys heard of that? So any number in the universe, if I add up all the digits and they make a fact, let's see, 8, 13, 15, 16, yes, okay. What do I get when I add up all the numbers in this? 3, 8, 15, 16, 18. Is that divisible by 3?
Yeah.
The whole number is divisible by 3. When I add them up, do I get a number that's divisible by 9?
Yeah.
Yes, so the whole number is divisible by 9. Those are the only two that have that rule though. 4, if the last 2 digits are divisible by 4 in any number, the whole thing is divisible by 4. That is just true.
If you add them together. Just
No. If the last 2 digits are a number that's divisible by 4, so in this case it's 12,
Yeah.
that's divisible by 4. If you try to divide this number by 4, it'll work. Has anybody ever heard? 6 is neat. How do I know this is divisible by 2? Because it is even. I don't know this is divisible by 3 because it adds up to be a multiple of 3. If 2 and 3 goes into it, doesn't 6 go into it?
Yeah, we think so.
So what's the rule for 6? The rule for 2 and the rule for 3 must both work.
Yeah.
You guys,
Number.
does anyone think they've never heard that before? We humans made this shit up. We totally made numbers up. We should know how they work.
You would think so.
So if you think you've never heard that, you should be a little bit angry. They're really, I know we have calculators. I don't care. We should still know how numbers work. I'm sorry, if you guys are done, you can leave. All right, I'm sorry. Be sure to think about going up on the terrace upstairs. They have like viewing stuff for the eclipse. Or now you got your little Weldon glass things. You can go out, put them on, take a look at the sun. Only through the glasses, dear God. Thank you. Thank you. Thank you. I want to go see if you can read 5 and see where. What's up, Brandon? You all right?